Right, number one, do you want me to draw it out? Is it okay? Was the Argand diagram okay with everyone for number one? Right, okay, for number two, right, you just had to add them or multiply them or whatever and then tidy them up, then draw them. Does anyone need me to do any bit of number two? Do the first part. Right, so 2 part 1, it's on freeze, sorry. Right, 2 part 1 reads 3 minus 2i, 3 minus 2i plus minus 1 plus 4i. Okay, so we're just dropping the brackets, okay, because it's adding and there isn't even a subtract in the middle, so I don't have to change the sign. So that's 3 minus 2i. A plus by minus is a minus 1 and plus 4i. And then, yeah, you put your real bits together. So your real bits is 3, take away 1, which is 2. And 2 minus 2i plus 4i is plus 2i. And then you plot. Okay, so plotting, that would be 1 on the real axis, 2 on the real axis, 2 on the imaginary axis. So 2 plus 2i will be right there. Okay, you multiply them. Okay, right. Does anyone need me to do any other bit of number two? It's okay. Number three. Anyone need bits of number three done, or all of number three, or anything for number three? No. Right. Okay. Great. We're on to the modulus of a complex number. So this is for your notes. Right, and you know the way the complex conjugate was the line across the z. Well, the modulus, girls, is if they put two straight lines either side of the z. Right, so if they put two straight lines either side of the z. Right, what the modulus of a complex number is, this is the distance from the origin. The origin is the point what? What's the origin? 0, 0. So this is the distance from the arrow to the point on the point representing the complex number on the Argand diagram. Right, so if I just had a complex number like the one I just had there a minute ago, I had 2 plus 2i there a minute ago, 2 plus 2i, right, and this is the modulus. The length of this line is the modulus of 2i. So it's the length, the distance from the complex number to the origin. Right, the length of this line is the modulus of 2 plus 2i. I am. I remembered. I'm getting good, aren't I? Yeah. Right, yeah. To keep reminding me though, because the day you don't remind me is the day I forget. The length of this line is the modulus of 2 plus 2i. The modulus is always a real number. because it's the length of a line, girls, it's always a real positive number, a positive real number. So it's always going to be a plus number, and it's also going to be real. What does that mean? There's going to be no what? I. There's no I. No, a real number can have a decimal, right? Okay, it just can't have I for imaginary. Okay, so the modulus is always a positive real number. Right, the writing got very bad there at the end, sorry. Right, there's a formula. And the formula is not, you know the way a lot of the formulas are in the log tables, this one is not in the log tables, right? Okay, so it's the modulus of a complex number a plus bi, z equals a plus bi. Yeah, are you all ready for me to move up the board? So the modulus, two straight lines either side, is equal to, girls, the square root of a squared plus b squared. Okay, please note there's no I at all. There's no mention of an I in the formula, so there isn't, right? Because it's the length of a line, it's a real number, right? There's no such thing as an imaginary length. It either measures something or it measures zero, right? Okay, so there's no I in the modulus, okay? So examples, I'll just do. So if I ask you for the modulus of 2 plus 3i, A, girls, is the real bit. So what is A? Yeah. What is A? A is the real bit. What's the real bit? 2. B is the number in front of the I. So what's B? There is no i's in modulus. So it's the square root, girls, of 2 to be squared plus 3 to be squared. Okay, no, please note no i's. You just take the real number and the number in front of the I, right? Okay, into the calculator with that, and that will give you the square root of 13, and you can leave your answer like that. So you don't need to turn it into a decimal. So if I ask you for the modulus of 4 plus, I'll go 4 minus 2i. Okay, so what would that be? The square root of what? 4 squared plus minus 2 squared. Now do this on the calculator, right? Why am I telling you to do this on the calculator? Because the amount of people in the room that are going to tell me when you square minus 2. When you square minus 2, what you get? 4. You get plus 4, right? I guarantee you loads of people in the room will tell me you get minus 4. You do not. That's why you use your calculator. Because if you use your calculator, you get the right answer, right? When you use your calculator, it's the square root of 20, but your calculator will spit out 2 root 5. That's just another way of writing the square root of 20, and that's right. So if you wrote the square root of 20 or 2 root 5, it's the same thing, so they're both correct. Right, one more. If I asked you for the modulus of 3 minus I, so what would that be? Be the square root of what? 3 squared plus minus 1 to be squared. Remember, it's the number in front of the I, right? There is no number, there's a 1 understood to be there. It's like x, right? X on its own, there's a 1 understood to be there, so that's minus 1 into the calculator with that, and that will give you the square root of 10. Is that okay? Yeah. Are we okay with modulus? Yeah. Right, okay, I'm going to stop recording. You're going to go to page 101. I'll put it up in a minute. Page 101, and really quickly, you're going to do question 1 to 12, right? They're all on the modulus, and when you've 1 to 12 done, we're moving on. So I'll stop and recording.